Sandworm also enables you to generate procedural buildings based on vector data. Let's start by adding a new buildings object and specify the building shape file from the vector folder. This type of objects expects closed vector shapes that represent buildings. The shapes and their attributes are used to generate three-dimensional building models. Let's add a filter to select certain buildings. In the attribute table, in order not to get lost in a large amount of data, use the search bar by attribute names. For example, let's filter out buildings by the number of floors. Some buildings here have a wrong number of floors. Also keep in mind that attributes may contain both numerical and literal types of data, which will define how the data is compared and sorted. Here the number of floors is a string value, so characters, not numbers, take part in comparison. Let's select buildings with more than 2 floors. The parameters of procedural buildings are available in the generation settings. There are 2 modes: automatic, with a small set of basic parameters, and manual for fine-tuning of all features of buildings and materials. The automatic mode is better for quick tests. The parameters enable you to specify the names of attributes to be used in generation. The attributes, compatible with OpenStreetMap geodata, are provided by default. You can always check availability of attributes by using the table from the filter section. The parameters are divided into the following categories: basement and walls parameters, roof parameters, and general settings. Let's take a closer look. Base material attributes and roof material attributes enable you to specify attributes defining the name of the material for walls and roofs. Sandworm looks for materials in the project for different parts of buildings based on the postfixes in their names. For example, if the attribute contains a brick value, that is, the house is brick, and asbestos is specified for the roof, the following materials will be used in the project if available. By default, there is one set of wall materials named plaster, and asbestos and asphalt materials for the roof in the core assets. In the very beginning, we included the procedural generation assets pack, containing additional wall material sets for various types of brick and concrete buildings. But the data source we are using has no attributes with material specified, so by default only the standard plaster material set will be used, meaning all buildings will have the same look. The floor attributes parameter refers to the specified attributes with the number of floors. 2 separated attributes specified here define the search scope. Roof type attributes contain attribute names with the roof type. Flat, skillion, gabled, and hipped roof types are supported. Roof height attributes is the list of attributes that contain the roof height. Roof unit size defines the tile size of the roof texture. You can use this parameter to control tiling of the roof texture. To diversify the look of roof from above, you can enable Use Imagery Color to write the color of the terrain surface right below each building to the vertex colors. That will add more diversity to the colors of the roofs and make the look closer to real landscape photos. In general parameters, you can specify grid spacing for buildings geometry. The default value of 100 kilometers separates distant groups of buildings for optimization purposes. The next group of parameters enables you to specify near and far visibility distances for buildings, as well as distances of smooth fading. To simplify rendering of multiple objects, it's worth limiting the long-range visibility distance of buildings within a single residential area. If you want to fine-tune the appearance of buildings, switch to the manual mode, which provides extra parameters of procedural generation of buildings, in addition to the basic settings. Base material distribution is the type of distribution of wall materials. Attribute plus random is selected by default, meaning that the selected material set is based on a value from the specified attribute and will be random if no such attribute or value exists in the source data. You can also make all buildings receive random materials. Materials will be picked from the random material list, which contains all material sets having the necessary postfixes found in the project. For each material set, you can choose the frequency of appearance. That is, now the white brick material will appear twice as often as other materials. You can also toggle off unnecessary ones. The next group of parameters is for customization of wall textures. When creating custom material sets, you will need to create a number of textures for the basement, ground floor, and upper floors with and without windows. Use the columns and rows per texture parameters to specify the number of columns and rows in your textures, while the column and row size parameters let you specify the size of one span in the building model. In fact, the row size parameter defines the height of one floor. By default, the number of floors will be taken from the specified attributes, and it will be random if no value is available. For number range defines a range of random numbers in this case. The same way you can define the distribution of roof types. By default, skillion roofs are the rarest. The height of each roof type. For example, the height of gable roofs will range from 2 to 6 meters. And a set of materials for each roof type. You can add and remove new values. If there are repeated types in the list, the settings of the last one will be used. Also, in the manual mode you can override the height of the basement and the underground basement. The latter one is necessary for avoiding hovering buildings over uneven ground surfaces. Let's start generation. Finally, we've got a procedurally created city based on the used geodata. Since we injected terrain surface colors for the roofs, these colors are available in the geometry of buildings as vertex color data. To enable colorization, click on a roof. By default, the material is read-only. To change its parameters, you need to create a child material. Then enable the vertex color flag and select or GB in the vertex color albedo parameter. Now vertex colors stored in the meshes are applied to the texture of the material and diversify the appearance of this roof type. The project is ready. You can quickly add volumetric clouds and water to the landscape, of course, if it should be in this area. In case you need to simulate smaller water bodies and rivers with flow, refer to our water and how to use flow maps video tutorials.